This conference will now be recorded.
Hi, this is Karen O'Brien, and today we're going to do a video on hazard mapping. So just a quick to get everything opened up and started. This is the Mapper program. When I install the software on your system, you don't get the Mapper program as an icon on your desktop. I just put that there. So if you want to do something like that, you can go to the Flow2D Pro folder, which is in your program files x86, Flow2D Pro, and just make yourself a shortcut from the Mapper program. Or you can get the Mapper program from the GDS. If you have the GDS open, you click File, Run Mapper, wherever it is, and run Mapper Pro. Once you have the Mapper program open, what you'll do is you'll read the Flow2D results into the program. I'll just use the standard lesson 6 because it's very simple. And you're going to be looking for the file fplane.dat. And this is what you get. You start out with your ground element map, and then these buttons are the other maps that you can use to set your maps. I'm going to focus on the hazard mapping, but I'm going to switch to a different project that has a little bit better hazard mapping potential. So I'll close this one for now. All right, so this is the project I have open and ready to go. This is a steep canyon that has a lot of flooding and mud flows, specifically mud flows. And we'll just quickly look at a couple of the maps for it. This is the flow depth. It's a rainfall model, so it has both rainfall and runoff. That's why there's flow depth everywhere. Right in here are the buildings. So this is the urban area. It's a very small village. And these are levees that are set up to protect this village, to keep the water away from these houses. And this is the main channel. It does not have any water because I didn't model the combined map. I just modeled. Here's the combined channel and floodplain map. So you can see the depths in the channel too. This one takes a bit longer to map. All right, and here is the depth in the floodplain, depth in the channel. And as you can see, the colors change a bit because our channel is quite a bit deeper, so it makes our floodplain, makes it look like there's less water on the floodplain. It's just because the colors have shifted. Okay, let's take a quick look now at velocity. This is the maximum velocity on the floodplain. Maximum velocity in the channel is just a, whoops, I have to be careful with my mouse. Every map for this project takes a bit of time to map because it's a fairly large project. And this is the maximum velocity. So what we're doing today is hazard mapping, and hazard is always a combination of depth and velocity in some way. Now in Flow2D, our combination is, if we have different kinds of mapping, we have water mapping, mud and debris mapping, USBR mapping. We also have flood hazard map that takes into account different debris factors. So we're going to focus specifically on the water mapping and then mud. And for this project, let's see again the hazard, the first hazard map. So in this case, if you do the water flooding, your hazard will become a combination of depth or depth times velocity. And you have control over these variables, and this is either in feet or meters, whatever, feet or meters per second, whatever you might have. And if we just compute using the default numbers, we'll show you a hazard map based on that criteria. So here's the hazard map for that criteria. You can see that it's a pretty dangerous place to be for the 100-year event. Obviously, it's a very steep canyon, so that makes sense. And if you come back to the hazard map and you check it out for mud and debris flow, you can see that the variables change. The hazard is adjusted because assuming that there's large chunks of debris floating in this mess, it will be, a lot more dangerous. So let's just try this one here. And just focus on these areas in here where you see a lot of red. You're going to see that it basically just expands so that everything is red. And we have the hazard mapping for the United States Bureau of Reclamation. And the different categories for Bureau of Reclamation are houses, mobile homes, vehicles, adults, and children. So we're going to do adults, and we're going to map this. And then while that's mapping, we'll take a look at this PowerPoint slide for the U.S. Bureau of Reclamation hazard for adults. So this is the way that the BOR set this up is they do these curves, and if you're under a certain curve or in between two curves, that is your associated hazard. So it'll be a relationship of depth to velocity just based on a spreadsheet. And so that's the way that we set it up. So low hazard would be under this curve, medium hazard would be between the two curves, and high hazard would be anything above a specific curve. And so if you are within these zones, you get the hazard designation. Now let me come back here. So one thing to note, that this was a rainfall model, so it's going to look a little bit different than the hazard map because versus depth versus velocity. In this case, everything is going to get a color. So you can see the color stretches across the whole thing because there's always a depth. And in the spreadsheet method, there's always like a low hazard. There's not really a measurement for zero hazard because there was water, because there was rainfall on the map. So even though it was only a few inches of rainfall, it's still just going to get that designation of low hazard. So you might want to do some adjustment based on that. So this is the hazard mapping. So obviously, if you were an adult in this area, there would be a risk to your life. This is how the BOR looks at hazard. Okay, so this is the BOR from their technical memorandum. And let's see. And these are kind of like the hazard categories. So if it's red, people are in danger, both inside and outside of structures. People are in danger. If it's orange, people are in danger outside of structures. And if it's yellow, their danger to people is low. But maybe buildings or structures may be affected. Now, if you have a different way of assessing hazard, that's okay, because you can take the depth and velocity data from this map and you can apply it to your own project using your own field calculators. So I'm going to show you that, hopefully, right now. Excellent. Okay, so I'm going to close this. So this is the same project, only now I have imported my depth and velocities as point files, and I've imported that shapefile from Mapper as an elevation. So let me show you what I mean here. If I come back to the Peralta project, every time in the Mapper program, every time I click one of these maps or load one of these maps or whatever, it creates the shapefile. And then you can take that shapefile and you can use it anywhere else. Hold on, I need to get in here and get into the actual project. And let me go down to the shapefiles and let me sort by the type. So you can see all the shapefiles that have been mapped. So these are all the shapefiles that have been mapped for this specific, whoops, I only need these for this project. So once you have these shapefiles mapped, you can use them in any other program. But you probably want to be careful, because if you come to your Mapper program and you try to import a shapefile into QGIS, then it may render your Mapper program. You won't be able to use it anymore. So you got to close it out first, and then we can take any of these shapefiles into a different software. Now, it brought it in with the wrong coordinate system. So I'm going to just change that real quick. I'm going to set the coordinate system and click OK. And the color is bad because the shapefile didn't have the color defined because it's a very simple shapefile the mapper program creates. So if you double click it, you can go to the symbology, and first of all, let's just get rid of this line. We don't need an outline. And second, we don't want a simple fill, we want a graduated fill. And our graduated fill column comes from the field variable. And let's see, we are doing a hazard map, so we might want to do colors of red, green, red, yellow, and red, yellow, and orange. Let's see if they have something like that. Here we go. Here's oranges. That might be orange to red. Oh, that one looks okay. You can actually set these up yourself based on the color, but just for simplicity, I'm going to leave it like this. And I'll classify it. Now, the values are, now these values are, there's only some values. There's values of 1, 2, or 3. So 1 being low hazard, 2 being high hazard, and 2 being medium hazard, and 3 being high hazard. That's what the hazard mapping values are. So you can actually set this up in here. So you can say that, first of all, we don't need 5 classes, we need 3. And this will be 1 to 2. And this will be 2 to 3. Or let's say 2 to 2.9. And this will be 2.9 to 3. Yeah, that should work. This will be 1 to 1.9. Yeah, that should work. And let's see how that looks. Okay, so here is your hazard map. And let's take that off. And we'll take that off, and we'll take that off. Okay, there we go. Nice. And you can change those colors to anything you want to make it look more like red, yellow, and orange, even though those are not exact colors. You can change those as well. So again, if you just double click on that, you can actually change that to a bright yellow. And same thing here, we'll change this one to a bright orange. Should be that guy right there, should be okay. That's close enough. And this one we can change to a bright red. Let's go like maybe here. Or you can just, I think you can just give it like red 250 or 255, whatever it is. I think it's 255. And okay. Yeah, that's better. There. And there you get your red, orange, and yellow hazard. So now you have this mapped in the program. You can give it a background image. Let's go. I think, let's see. I'm not sure why that gave me did not load an image. All right. Well, that's unfortunate. I'm not going to get an image, but that's okay. So you can give it a background image. This is the program Quick Map Services, and I have just recently upgraded to like the nightly build of 3.5, so probably would have been better to stick with like version 3.2. Maybe I need to update my app, my plugin or something. Okay, so that's that. Now, what if you don't like or you need a different kind of calculation to map your hazard? Okay, you still have some options. So you can take the velocity file from your Flow2D run, and you can take the depth file. Let me show you these two, the location of these two files. They are, so here is the floodplain velocity, and this is the floodplain depth. Okay, these are the two files that you can import into QGIS and use to calculate any kind of velocity or any kind of hazard that you want. So what I did was I brought my Peralta study, and that gave me the coordinate reference system for the project, because this data won't have a coordinate reference system because it doesn't have a project file. It's just raw data. And this elevation at cell, this hazard map, that came from Mapper. It also won't have a coordinate reference system because GDS and Mapper don't use coordinate reference system. They just map the data. They don't care what coordinate system it's in. So I load the data, I get my coordinate reference system, and then I start pulling in the rest of the data. Now, usually what it'll do is it'll set it to your project coordinate reference system. But if it doesn't, you can always set it from, oh, I'm sorry, it's not here. It's a right click, not a double click. You can always set it from somewhere around in here. Yeah, right here, set the coordinate reference system. Okay. And so then I bring in this elevation at cell. This is just a generic shapefile from the Mapper program or GDS program, the mgrid.shapefile. That you can also bring that one in. The reason I have this is because it has the correct positioning of all of the cells and the correct size and everything. It just puts the shells in as a polygon. Okay, so now we have the data in. So this is the way you do it. You can take this one from the program, elevation at cell, and you can drag that onto the map. And then you can import from elevation or from text files these other two. So if you add a layer, you can say, okay, this is a delimited text layer. The file format is text. I have a custom delimiter and it's space. The first record does not have field names in it, so I uncheck that. I trim the fields and I make sure to discard the empty fields. Of course, obviously, first thing you have to do is tell it which file you want. And this just points you to your files, and we want depth fp.out. I'm not going to do it right now. Well, I can do it. I can just, okay, then we see here that we have space delimited. If we take all this stuff out, it has a bunch of extra fields in here. So trim the fields, discard the fields, and uncheck that the fields have record names. And then you can set your coordinate system here. And one last, oh, and then set your X field, which is field 2, and your Y field, field 3. And the rest of it is just click add. And once you click add, it's going to add it to your map. And let's see what, so you do that with both your depth and velocity. And then you come to your elevation at cell and you want to make a join. So I'm going to go to the joins properties, or the joins, whatever you call that. And if I double click on one of these joins, you can tell it'll show you what it is. Okay, so this is the depth layer. So that's this guy right here. I'm going to depth layer field 1, that's grid element number, will match the ID field of the elevation at cell, because that is also grid element number. And we don't want to join all the fields. We only want field 4 because that's the field that has depth. But obviously field 4 doesn't say depth, so what we can do is just put a D right here, custom field name prefix, and put a D. Then when you click OK, it adds the field. And you can see here, this is what you've just added. This is what you've just joined. So I'm going to click OK. Or actually, I'm going to click cancel because I've already done the join. And now I'm going to open the attributes of this shapefile. Now this is a shapefile, so it's a lot of data, so it kind of takes a long time to load. So I'm just going to right click it and click open attributes because, but it's going to take a while. So just bear with the program here for a minute and let it do its thing. Okay, these are the features that it's loading. And this is the reason why it's not always the best idea to do this from a shapefile, because shapefiles take forever to calculate. So raster, so doing this from a raster would be a little bit easier. But I'm going to show you both ways, because if you have a small project, you can do whatever you want. Now this is the hazard column. So what I did with this is I clicked the editor pencil and then I created a layer. I clicked new field and I named it hazard. And I set it to a real number. And the length of the number is, let's see, I mean, hazard is 1, 2, 3. So actually hazard could be a whole number. So yeah, let's give it a whole number integer. Yeah. And the length could be 1, 2, or 3. So the length can be 1. And then I'll click OK. And what that should do is it should give me a new field. And I'm just going to give it time to load all the features. Okay, and you see here that I have a new field called hazard that is empty. So I can come to this calculator, click hazard, and I can click, let's see, that would be, this will open the field calculator. So I open the field calculator, or the expression dialog, sorry. So whatever expression we put in here will be applied to this field. And you can, so then you can come down here to fields and values, and you can do any combination of these that you want. So let's see, so this hazard was depth times velocity. So for this one, we could do like depth times velocity squared, just for fun. So you double click the field you want, and that should add it. That should add it here. And then times, whoops. And then the next field is velocity. And then we can just go squared. But I think we might need to put this in a parenthesis, just in case. And that would make, I don't think we needed to do that, but just in case, I'm not quite sure. And then just click OK. And then here, over here, you want to say update all. And it tells you, because you see that it's black, that means it's a valid expression. If it was red, it would be an invalid expression. Okay, now it's loading the features. So again, we'll just let it do its job. Wait a second, did I mess something up? Oh no, okay, so let's kind of quickly go down through here and see if we can find, yep, there we, oh, come on, dude, we cannot have hazards that are, oh, you know what we did? It can't be depth times velocity, because that's an actual number. So hold on, we'd actually have to make it, all right, let me give me that back here. That doesn't make any sense. Sorry. You have to make your coloring 1, 2, 3 based on the hazard level, but this is the actual calculation. So let's try it again. So I can't change this one. I just have to delete it, because you can't change, for example, I can't take this field and set it to change the number type. I have to delete it and start over. So instead, I'll just put it right here. So I have my hazard. This time we'll change hazard, and then we'll just do update all. Okay, and again, just leave it alone, let it do its thing. Okay, so here are the hazard values that it's calculated. And I'm going to just do this one time. I'm going to just click this, and it's going to sort the whole table by high hazard. But it's going to take a bit of time, if it does it at all. I hate clicking on it again, because then you won't know that it's, oh yeah, it's working, because you can see that it's sorting it. So what it's going to do is it's going to sort this from high to low so that you could determine the high hazard. Then what you have to do is take this high hazard and apply it to a color scheme. And the color scheme would be something like, maybe like this, where a certain color represents, this combination of values. And I'm hopefully gonna see it here in a minute. Oh gosh, now that was maybe a mistake. Oh no, wait, it's open. Oh, I see, it did it backwards. Okay, so let's just go to the bottom then. There, and so here's our highest values. So you have to just develop a system that will take your d times v squared and apply it to a hazard colorization category. And so I'm going to save this, and I'm going to exit it. Oh, for crying out loud. It always has to load everything after you do anything. Okay, give it a second. Now it's writing, probably what it's doing now is it's writing the data to kind of a temporary data set, would be my guess. Or writing the data to the, everything was stored in the temporary data and now it's committing it to the shapefile. And I think that actually takes kind of a long time. So I think what I'll do is I will pause the video and then we'll come back when it's finished.
This conference will now be recorded.
Okay, when I stopped the recording, we were saving this data to the table. And because this is a vector map, and there's a lot of cells in this map, it took a bit of time to do the save. Let's just see, maybe quickly we can go to the bottom and see 150,000. So maybe working with vector maps, if you have a really good computer, is fine, you know, up to about 1 million cells. But once you're over that, you might want to switch over to raster mapping, because vector mapping just kind of slows things down. I'm not going to cover raster mapping in this video because it would take too long. I'll do it in a second video. But what I did was I made the raster calculation, and then I had to determine a way to convert that raster numbering to colors on the map. And I really just did it by trial and error. And so if I open this color map or color template, you can see here that you can do whatever you want. So first of all, I wanted to get rid of anything that had nothing to do with a hazard. And then I just started to simply put some different numbers in here. Let me just change some of these values and click apply to give the map some color. But that's not the way that you want to do it. Obviously, you want to do it with a mathematical sense of, you know, of something that actually is a hazard. So hazard is calculated, the depth times the velocity squared is calculated and in the field, but you still have to use that to define your hazard. And then basically you do that based on whatever country you live in and how they define hazard. And then I just came into these symbols and I changed each one of them to the color that I wanted. Like this one actually says it's green. It's supposed to be yellow. Actually, I think it's just because I'm clicked on it, it changed it. Yeah, it's just because I'm clicked on it. And then you can define the hazard, draw the map, and then set up your map template with QGIS, which again will have to be a different video, and then report your results to whatever agency you want. Now, the good thing about this being a vector map is that you can actually go in and you can delete anything that's under a certain hazard and just completely get rid of that portion of the map. If it's a raster map, you can't do that. And so I think that's basically it for hazard mapping. That's really all I wanted to show you. So I'll go ahead and stop the recording now. And the next thing we'll do is raster mapping. So come back for a video on raster mapping.